Now let's look at a scenario where we add base to a buffer. Any base that we add to this buffer is going to react with the acid component of the buffer. So let's look at an example. We're again using 0.8 molar lithium fluoride and 0.8 molar HF. Ka is still 7.1 times 10 to the negative fourth. And now this time we're adding 0.1 moles solid sodium hydroxide to 1 liter of the buffer. Now this is already given to me in moles, so I don't have to do anything to it. But if I'd given this to you in grams, obviously you would need to convert it to moles. The initial pH of the buffer is 3.15. So the first thing we need to do is figure out the concentration of the hydroxide ion that we add. So that's just moles over liters. So 0.1 moles over 1 liter, or 0.10 molar. Again, just a reminder that if I had not given that to you in moles, if I had given it to you in grams, you would need to convert that to moles first. Now, the hydroxide that we add is going to react with the acid component of the buffer, producing water and the fluoride ion. Technically, you would have the Na in there or the Li in there, whatever those spectators are, right? But they're not participating in the equilibrium. That's why we can omit them from our reaction here. All right, so the initial the initial concentration of HF was 0.8 molar, and there was 0.8 molar lithium fluoride in there as well, right? So those were the amounts given to me in the problem. This is the amount that we added. We just calculated that. Now this hydroxide is going to fully react with the acid, meaning that the amount of hydroxide that we add is going to go all the way down to 0. So that means that we're subtracting 0.1 from this side. So we need to subtract 0.1 from this side as well. And if we're subtracting 0.1 over here, we need to add 0.1 over here. So our equilibrium concentrations are 0.9 and 0.7. Now we use the Henderson-Hasselbalch equation. pH is equal to pKa plus the log of A minus over HA. The pKa comes from taking the negative log of the Ka. So taking the negative log of 7.1 times 10 to the negative 4 gives me this value. And then when I do the log of 0.9 over 0.7 and add it to the pKa, I get 3.26. The initial pH was 3.15. It went up to 3.26, which is what we would expect from adding a base. But that change in pH was very minimal, and which will lead us to conclude that this is an effective buffer.